Babylon mapped constellations so precisely they predicted eclipses 3,000 years before anyone owned a telescope. What we call modern astronomy, the systematic study of the heavens, didn't start in Renaissance Italy. It started in clay. Around 1800 BCE, Babylonian priests stood on the flat rooftops of Mesopotamia night after night, recording the positions of stars and planets onto wet tablets with nothing but their eyes and a stylus. No instruments, no lenses. Just obsessive patience and a civilization that understood something crucial: the night sky wasn't random. It was a conversation waiting to be decoded. Here's what most people miss: these weren't casual observers. The Babylonians had mapped at least 200 individual stars and organized them into constellations. They tracked the moon's position through its 18-6-year cycle, a period so long that proving it required multiple generations of unbroken records. They didn't know why the moon did this, they just knew it did, and they wrote it down. By 1600 BCE, Babylonian astronomers had compiled enough data to do something extraordinary: predict lunar eclipses. A lunar eclipse isn't random. It happens when Earth slides between the sun and moon, casting a shadow. But to predict when that shadow will fall, you need to know where the moon will be months or years in advance. You need mathematics. You need the sky charts they've been building for centuries. Around the same time, on the other side of the world, something equally remarkable was happening. In the Indus Valley, around 1500 BCE, astronomers were using stellar observations to align their cities and temples. The Vedic texts, India's oldest written records, contain descriptions of star positions so precise that modern scholars have used them to date the texts themselves. They weren't just watching the sky. They were using it as a calendar, a compass, and a clock all at once. But here's the tension that runs through all of this. None of these astronomers understood what they were seeing. They could predict where the moon would be. They couldn't explain why. They could align temples to Polaris, the North Star. They didn't know that Polaris marks Earth's axis or that the axis slowly shifts. They were working with perfect precision and profound ignorance at the same time. Jump forward to 280 BCE, ancient Greece. Aristarchus of Samos published a radical claim: the Earth orbits the sun, not the other way around. He'd done the math, he'd measured shadows and angles, and he was right, completely provably right. But here's the devastating part: almost no one believed him. His idea vanished for nearly 2,000 years. In China, meanwhile, astronomers were building the most comprehensive star catalog the world had ever seen. Around 150 CE, during the Han Dynasty, they'd recorded over 14,000 observations spanning centuries. They tracked supernova exploding stars so bright they could be seen in daylight. In 1054 CE, Chinese astronomers recorded a guest star so luminous it remained visible for weeks. We now know that was the Crab Nebula. They saw something Europeans wouldn't document for another 600 years. The Islamic Golden Age, roughly 750 to 1250 CE, took all of this ancient knowledge and weaponized it with mathematics. Astronomers like Al-Farghani and Al-Battani refined the star catalogs they'd inherited from Babylon and Greece, adding hundreds of new measurements. They calculated the Earth's circumference to within 5% accuracy using nothing but angles and stellar positions. They were doing astrophysics before the word existed. By the time Galileo pointed the first telescope at the sky in 1609, centuries of naked eye observation had already mapped the heavens. The telescope didn't reveal a new universe. It revealed fine details within a universe that had already been charted, measured, and understood, at least in broad strokes. Galileo was reading a book that ancient astronomers had written across 3,000 years. What made all of this possible? Obsession. The Babylonians didn't invent the telescope or the spectroscope. They invented something more fundamental: the idea that the sky could be studied systematically, that patterns could be found, that records mattered. They believed the universe was legible. That belief, more than any instrument, was the real revolution. The forgotten astronomers remind us of something we tend to forget in an age of satellites and space probes. The human eye, when paired with curiosity and time, is a powerful instrument. Ancient astronomers had no light pollution to fight. They had clear skies and generations of collective memory. They had something we've lost: the patience to watch the same thing night after night for decades, waiting for pattern to emerge. Today, we stand on their shoulders. The constellations we name, Orion, Cassiopeia, Andromeda, were mapped by astronomers who lived thousands of years ago. The lunar eclipse predictions we can make depend on the cycles they discovered. The very idea that the universe follows rules, that those rules can be discovered and recorded, came from them. They weren't looking at the stars for wonder alone. They were looking for meaning. So the next time you look up at the night sky and recognize a constellation, remember, you're reading a text written in light and time by people who have been dead for millennia. They couldn't explain gravity. They couldn't explain why stars shine, but they saw, they watched, they recorded, and they passed it on. That's the real inheritance of ancient astronomy: not answers, but the commitment to asking questions and trusting that the answers are worth finding. Subscribe so you don't miss the next untold story. Every week we uncover the forgotten missions and surprising discoveries that reshaped our understanding of space.